Space is pretty dope. It can be beautiful, magnificent, and sometimes even terrifying. We take pictures of stuff like this and this, but there's a rather disappointing truth behind many of these magnificent images. The vast majority actually looks like this. Or at least there's not much we can see. We are able to see the bright parts, stars, cosmic dust, and if they're close enough, the occasional orbiting planet. But with the assistance of technology, not only can we see much further into space, but we can also see much more than the naked eye ever could. So instead of this, we'd see this.
This photo was taken with an infrared telescope. What is infrared, you might be wondering? This chart shows the electromagnetic spectrum, of which visible light is a part of, but it's only a tiny part of the total radiation spectrum. Infrared is the energy level just below visible light. This radiation is usually referred to as heat. All matter in the universe gives off some amount of electromagnetic radiation, no matter how minuscule. The best example of an infrared source is our closest star, the Sun. While we see the visible light, we feel its infrared emissions, even 93 million miles away. Since infrared's wavelength is longer than visible light, it's able to punch through obstructions like gas or dust without getting absorbed. But you might be wondering, why are infrared pictures so colorful if our eyes can't detect it? The process of making one of these photos has two parts. First, there's the black and white light exposure, and then there's the data analysis. There are actually two reasons pictures start in black and white. Reason number one is the fact that color photos are inherently lower resolution than raw exposures. Black and white images take a picture with the entire photosensor, and as such, the entirety of the image processing is dedicated to collecting as much light as possible, which then increases the total overall resolution of the image. With color photos, on the other hand, when taken with the same size sensor, each color collects a fraction of the available light. Then, the layers are stitched together, creating a lower quality color image. Reason number two is due to the fact that much of the light hitting the sensor isn't actually visible to the human eye, the most prevalent of which is infrared. The second part of making the photo is the data analysis. When the camera takes an image, it also records the frequency of light hitting the camera. These frequencies vary from element to element based on the total amount of energy each element has. This is called an element emission spectrum. Take this chart for example. At the top of each element, there's the element's respective absorption spectrum, or what type of light it actually blocks. Below each of those is the emission spectrum I mentioned before. So, if we look at sodium, we see it absorbs primarily light ranging from 500 to 700 nanometers. And then, it re-emits the light at a lower wavelength, that being closer to about 450 nanometers. Here's another example. Take 144 Hz. That frequency of light doesn't actually have a color in the visible light spectrum. But by taking the data recorded by the telescope, scientists are able to compare it to the known emissions of a specific element and assign a color to each of the elements in the image. This entire process is the reason we get crystal clear color images from deep in space.
So why exactly are these photos important? By taking these photos, we are able to see the hidden mysteries of the universe and learn much more than our eyes could ever tell us. Everything revealed through infrared photography has allowed scientists to better understand the physical and chemical makeup of discovered stars and planets. This knowledge allows us to discover exactly how our universe works, and even opens the possibility for future colonization. From the fiery births of our stars and their explosive ends, or to peer back in time to the beginnings of the universe itself. Little by little, one photo at a time, we learn more about the universe around us.